Okay, so now we're going to start working with z-tables. So hopefully you saw that there was attached to this module when you were looking at the content, there was a z-table. So this z-table, we're going to use this. We also have the TI-84. It's going to do some of this for us. But we're going to first use the z-table, and then we're going to do some of these same problems again, but we're going to use the TI-84. Partly because z-tables are a common thing that we use, and sometimes some people find them a little easier to work with. So just to show you how a z-table works, the image is pretty much telling us what we're expecting here. So as you see here, as you remember, this is a standard normal curve because it's centered at 0. And we're assuming, because like I said, we know this is supposed to be a standard normal curve, that means the standard deviations are going to be 1. So what a z-table requires us to do is to look at z-scores, because z-scores are on your standard normal curve. And you see this little shaded area here. What that's telling you is that if I have this z-score, what my z-table is going to tell me is this area. And what this area represents is this is going to be the probability that your z-score is going to be less than whatever this number is. So if it happened to be that your z-score, let's say, was 1.5, then this area here is going to represent the probability that if I had a z-score, a random z-score, that's going to be less than 1.5. Also, you can say this as well, less than or equal to 1.5. So those are interchangeable as far as when we're dealing with these probabilities in a continuous normal curve and a continuous random variable. Okay. So let's say that my z-score was 1.28. The way we read z-scores is that we always are going to cut like this. So z-scores should usually, when we're doing any rounding, are going to be rounded to 100th place. So 2 decimals. You may have noticed that anytime we were dealing with z-scores, we tend to round them out to 2 decimals. That was because we're prepping for the z-table. So any kind of score I have, we're expecting that it's going to be to the 100th place, and then we use the z-table. So let's say our score was, like I said, 1.28. What you're going to see here is that your z-table has 2 parts. We have a negative z-score. So as you see, z is to the left of 0, so it's a smaller value. So you're going to have negative z-scores. And then we have the second part of our table where we see that we have z-scores that are to the right of 0. So this means they should be positive z-scores. So like I said, it's split like this. And what you're going to do is you're going to look for this part is going to be in the column. And this number here means that we're going to look for 0.08 in the, sorry. Yeah, we're looking this in the row on the top. Okay. So as you see here, right here is my 1.2. So I'm going to highlight this whole row here. And then we're going to look for the 0.08, which is up here. And this overlap right here is representing this probability. So assuming that z was actually 1.28, this area here, that is going to be the probability that my z-score was less than 1.28, and that area is going to be 0.8997. So it represents this area and this probability. So you're going to hear us talk about areas and probabilities interchangeably. So every time we talk about an area, we're really talking about a probability. So as I said, this area here is going to be 0.8997. But this probability as well that z is less than 1.28 is 0.8997. So z-scores are only, or z-tables, I'm sorry, can only tell us area that is going to be to the left of the z-score. So z-tables only tell us the area to the left of the z-score. So that is going to be whatever our z-score is, it's going to be left than, so usually we use that big Z, is going to be less than Z. And this first one here represents the z-score. Okay. So right here, we're going to have pictures of the areas and parts of the z-score on these slides, so we don't have to keep going back to the table, but we will eventually start going back to the table again. So like I said, you may, the table may be used to find the area that is to the left of a given z-score. So it's always going to be the area to the left. So that's the part to always remember. This will change when we talk about TI-84. So if I want to find the area to the left of z equals 1.26, oh, I was so close to guessing it. What we're asking for is this area here. And once again, we said that represents just the probability that if I had a z-score, randomly any z-score, that would be less than 1.26. So if I took any value of x and I found a z-score for it, we're looking for the probability that z-score would be 1.26 or less. Like I said, just always remember that in this case, these the inequality, the strict inequality and the less than equal to inequality are actually the same. And as I said, we're just splitting the score like this. So we just have to look for the 0.2 and then the 0.06, and we just look for where they come together. So the probability that if I took a value and I found a z-score for it, the probability that that z-score would be 1.26 or less would be 0.8962 or 98.62%. Or the area that is to the left of the z-score of 1.26 would be 0.8926. So one of the things I said to watch out for is that sometimes you're going to have a negative z-score. So that means that we have to look at the other part of our table where we look at the negative z-scores. So if we want to find the area to the right of a z-score of 0.1, of negative 0.58, remember what the z-table is going to show us is this. So this is 0. We're looking at this score over here. So the z-table is going to find the area to the left. And we want this. We want the area to the right. So we don't want the area to the left. Well, the solution to this is, if you remember, this whole entire area altogether, I did a whole distribution and I did that whole area. We know that total area is going to be equal to 1. So our solution, if we're trying to find a z-score or an area to the right, first we need to find that z-score. So as I said, we're looking at the negative z-score, so this is going to split like this. So we have to find a negative 0.5, which we have right here. Then we have to find the 0.08, which we have here. And this is my overlap. So this area here is going to be 0.2810. So that means right here, that's this area. But we want the area on the other side. So if we want this area now, we're just going to take 1 because that represents everything and subtract 0.2810. Just a second, I lost my answer to it. 0.801. So we end up being left with 0.7190 technically. So that's this area over here. Now when we're talking about area to the right, we're talking about that area to the right that is going to be greater than that z-score. So this is the probability that if I had a random z-score that is going to be greater than negative 0.58. Or z is greater than or equal to negative 0.58. Either way, what we're going to get is that our area is going to be, or our probability is 0.719. Or 71.9%. Sometimes we're going to find the z-score that is between two numbers. So in this case, we want the area that is between a z-score of negative 1.45 and 0.42. So what we're looking for is this area here. So another way to look at this is that you're looking for an area between two z-scores. That area is represented as the probability that my z-score, well, is in between these two numbers. All right, so before we go forward, we're going to need to go back to those z-tables. Okay, so like we said, we're looking for a z-score that would be between negative 1.45 and 0.42. So we're trying to find that area, which that is equivalent to saying that I wanted the probability that my z-score is going to be between negative 1.45 and 0.42. So remember, areas and probabilities are the same. So what I'm looking for is this. Assuming this is all z-scores, I want this area here. So remember, everything that my z-table does is just gives me an area that is to the left. So I need to find two areas. Oops. Let me draw that again. So I'm going to draw my little curves here. So if I look at my z-score of negative 1.45, I'm going to get this area. If I look at my z-score at 0.42, the z-table is going to give me this area. And what I really want is this area. So let's first find my areas. So if I look for my first one here at negative 1.45, we need a little scrolling here. So we start with the negative z-scores. Here's my negative 1.4. Now I need my 5, which is here. Sorry, kind of caught my board there for a second. And we're seeing that this is that area. So this area is just going to be 0.0735. All right, so now we need my other area. That means I need a positive z-score now, so we're going to go down to this table. So this is 0.42, so we split here, and I look for my 0.4. And then I look for my 0.02. So we see right here, that is going to represent this area. So if I want to get this area right here, remember that this area, well, I could subtract it from this area right here. And if I do that, I'd be left with this area. So all I need to do to figure out this area in the center is to take my 0.628 and then subtract the 0.0735. So basically I'm taking the smaller area and subtracting from the bigger area because that's going to tell me what is in between them. So we'll have 0.6628 minus 0.0735. And we're going to get a 0.5545. I'll write that again over here. So this area is 0.5545. So the probability that if I took some value, I found its z-score, that its z-score would end up being between negative 1.45 and 0.42. That probability is 0.5545 or 55.45%.